formulas and you revised. No. I told you that I'm going to give you a test. I'm talking to you. Oh, hello, I'm talking to you. I'm not bothered about that. I'm talking
Fourth
to you.
chapter.
What did I tell?
Formula.
Kaushik is in the same school as you? No? You're all from different schools?
Virat and
Bagbai.
Bagbai one school, right?
Yes, I know.
Then Kaushik FPJ school. And you are Abhishek. Oh,
Abhishek.
DPS. And I am in Amrita Vidyalaya.
Where is
You
it?
know?
Where is it?
Huh?
Where is it?
Vijayanagar.
Come.
Never then
Name many people. Only two of them today.
somebody exam.
Sign. Finished? You finished signing? Shall we start? Okay. So today I'll be talking about the different, different models. So this is what I'm going to talk. Thomson's atomic model. Can you see that? Your textbook you have? So right now we know about the structure of the model now. Structure of an atom. This is the nucleus. And you have got various orbits in which the electrons are present. Correct? This is the correct one. But I'm just taking you back to see how the different structure of the atom was introduced by different scientists. You should appreciate the fact that way back in about 1800, 1900, the number of instruments which were available for scientists was very less. So first one was regarding Dalton. And what did Dalton tell us about the atom? Atom was supposed to be neutral. Correct? And we also said that it is the smallest particle of any matter. So that was another point that he stressed on. And then he said that the smallest particle will react with the others and that how new substances can be formed. So that was Latin's postulate. So in the beginning of the late 1800 and beginning of the 1900, so there were a lot of scientists who wanted to know what is it, what is present, and what would be the shape, what would be the structure of an atom. Okay. So the first one who put forward this theory was regarding Thomson's.
So this one is remaining.
Which one?
Isobaric.
Okay. So first let's talk about what is Thomson's idea. So Thomson knew. Okay, so we'll talk about Thomson body, and he knew that the atom is neutral, but at the same time he also knows that there are some negative charges and positive charges. So he was able to tell us that negative and positive charges, both of them are of the same value. So suppose you have got 10 negative charges, there should be 10 positive charges. So this is what he thought of. So what did he say is, first of all, an atom is nothing but a sphere, and it is a sphere which contains positive charges. Did you understand? Okay. So this is how he said that there are a lot of positive charges in which the negative charges are embedded. Okay. So you have got your negative charges which is embedded here like this. Come. I have you will come. Exams will come. Okay, so this was Thomson's one, right? So how does it basically look? It looks like watermelon. Suppose you cut a watermelon, you feel that red part of it in which those seeds are embedded. Okay? So the red part of it is nothing but the positive charges in which the negative charges are embedded. Or otherwise you can think of a pudding, cake or a pudding in which the raisins are embedded. So this was accepted for some time, but at the same time many people started wondering why it should be embedded, what is the structure, is it the correct structure and so on and so forth. So the work for him, the amount of work that he has done and for the amount of research that he had done, obviously gave him a Nobel Prize. You know what is a Nobel Prize? It's one of the highest prizes of recognition given to the scientific community. So now, slowly every year, you find that Nobel Prizes are given. Okay? And very, very recognized, and it is supposed to be an extremely, well-deserved prize. So it was actually Thomson, and he got this Nobel Prize in 1906. So when did he get this prize? It was in 1906. It was his turn, and he got it in physics for recognizing that there is presence of electrons also. But then later on, of course, this particular model was not at all correct because it was another scientist who was Rutherford. Okay? Rutherford, he wanted to find out where are these negative charges, where are these positive charges present, how are they present, and so he started completing or he started devising another type of an experiment. And this experiment is what is known as a gold leaf alpha particle experiment. Do you understand? Why did he take gold leaf? Gold leaf is because very thin sheet of gold leaf can be taken. Okay? He wanted less number of atoms. So a thin gold leaf is possible because gold is highly ductile and malleable. So it can be beaten up into thin sheets. It's extremely malleable. So suppose he says that these are the atoms of a gold sheet. Suppose this is a gold sheet. Obviously, it consists of atoms. Okay. So what did he do? He devised an experiment in which he was bombarding certain alpha particles. Look at this. What is this sign? It is alpha particles. Okay. Now, what is the charge? Alpha particles are nothing but positively charged particles. Alpha particles we write like this, and it is nothing but helium doubly charged particle. Try to understand. What is helium? It's a gas. Atomic number is 2. Okay. So how many protons and how many electrons will be present for helium?
Atomic number is 2.
2. So it will be 2 electrons and there will be 2 protons. So let's draw the structure. So this is the, okay, protons there are 2 and I'm going to show you that there are 2 electrons. So this is 1 electron, this is the other electron. Correct? This is an atom, this is a helium atom. What happens if we knock off, or what happens if these electrons are removed? Suppose we remove these 2 electrons. So the thing that is remaining inside is nothing but helium positive charges. Helium plus 2 Is that okay? Did you understand? So what did he do is he started bombarding with alpha particles, and alpha particles are doubly charged particles. So he was expecting that if I am going to, send alpha particles, positive and positive charges will repel, because according to Thomson's model, it consists of positive charges. So you have got positive charges here. So actually it should repel. Most of the alpha particles should actually repel, but it did not. Okay, so what was his observation? His observation, he saw that most of these particles are passing through. Did you understand? So it was a remarkable observation that he was able to understand that the structure was entirely different. Okay? So he found that most of them are able to pass through. And he found that some of them are deviating. Okay, some of them are deviating. Did you understand what is deviating? That some of them are just deflecting at a slightly smaller angle. And then he found that only a very few of them are able to hit a target and they are able to come back again. Okay, some of them are not passing through. So he began to wonder and he was able to immediately say that this structure which was put by Thomson is totally wrong. Okay, so the structure is not possible. It cannot be possible that it consists of a pile which is full of positive charges in which the negative charges are everywhere. So he was the one, he proposed this model. Did you see Rutherford's gold-foil experiment? Did you see this one? How most of them are able to pass through. Some of them are deviating at very wide angles, and only few of them are coming back again. So based on this, he was able to propound, or he was able to say that this model is actually wrong. And he said something else. He said that atom must be having only a very small part which is positively charged. Okay. And most of the atom must be quite hollow, because he saw that most of these rays are passing through. Okay. So there is no positive charge present anywhere around. Okay. So he found that only a few of them, if it is hitting this target, maybe it is getting reflected. And so he said that maybe containing a core, a center point, which is positively charged, and that's how he started using this word, which is nucleus. And he said that nucleus has to be positively charged. You understand? So the presence of nucleus and the presence of the structure of an atom, as we know today, is because of this whole leaf alpha experiment. Did you get it? Okay. Let's read this part before I go on to Bohr. Okay, so the next model that I'm going to explain is regarding Bohr's model. Okay, so let's see that. You have your video version. Read that part. Yeah, first we will read structure of an atom. We have learned Dalton's atomic theory.
Created Thomson.
No, here. 4.2. We have learned Dalton's.
We have learned massive atomic history in chapter 3, which consists that the atom was invisible and indestructible. But the three of the fundamental part was
Which book are you saying? This is
not
And that
he is reading from here. But approximately calculated.
But the discovery of two fundamental particles, electrons and protons, inside the atom led to the failure of the aspect of Darwin's atomic theory. It was then considered necessary to know how electrons and protons were arranged within an atom. For explaining this, many scientists chose various atomic models. J. Thomas was the first one to propose a model for the structure of an atom.
Okay. So first one, of course, was Dalton's atomic theory. Okay. And we know about what Dalton has propounded. Abhishek, read the next one. Let us see what is given.
Thomson's model of an atom.
Yeah, you are reading it from the volume, no? Read.
Thomson proposed the model of an atom to be similar to that of a Christmas tree. The electrons in a sphere of positive charge were like currents, dry fruits, in a
Correct.
currents in a spherical Christmas tree.
Current is what actual kishmish we put in that is current. Results, currents.
Thomson proposed that an atom consists of positively charged sphere and the electrons are embedded in it.
Embedded.
The negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. Although Thomson's model explained that atoms are electrically neutral, the result of experiments carried out by other scientists could not be explained by this model.
Okay, so we have got something regarding J.J. Thomson here, this part of it. Okay, so he was a British physicist, right? And for his work, he was awarded a Nobel Prize in Physics in 1906 for his work on the discovery of electrons. Okay, and subsequently 7 of his assistants, okay, 7 of his students won Nobel Prizes. Just imagine, okay. He directed the Cavendish Laboratory at Cambridge
All
for 35 years. He was a professor in that college.
So all the 7 students were
They won the Nobel Prizes for their excellent discoveries.
Almost
Not 35 years he taught. And so many students were under him. No? So 7 of his students were Nobel Prize winners. Yes. Okay, so we are going to now talk about Rutherford's model. Do you have Rutherford's model? Can you read that?
Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. Rutherford designed an experiment for this. In this experiment, fast-moving alpha particles were made to fall on a thin gold foil.
Okay, wait. Read now, continue.
He selected a gold foil because he wanted as thin a layer as possible. The gold foil was about 1,000 atoms thick.
Okay, why did he select gold as his material? Because it is
Because
extremely
it's
malleable and you can get a very thin layer which consists of as little atoms as possible. Still, we are talking about 1,000 atom thickness. Okay, and the alpha rays are actually passing through all of them without getting negated, most of them. Right? Now,
Alpha particles are doubly charged helium ions. Since they have mass of 4u, the fast-moving alpha particles have a considerable amount of energy.
why does it have a doubly charged? Why does it have a doubly charged helium?
Because helium.
So why?
So if you remove those 2 electrons, the charges become positive.
Okay, so we have to remember that helium atom is one where it has got 2 protons and 2 electrons. If those 2 protons here are knocked off, okay, if these 2 electrons are knocked off, whatever is present inside is your alpha particle. Okay. Next point.
It was expected that alpha particles would be deflected by the subatomic particles in the gold atoms. Since the alpha particles were much heavier than the proton, we did not expect to see large deflection. But the alpha particles scattering experiment gave totally unexpected results.
So it's absolutely different. Okay. Had it been a plum pudding model, then many of these alpha particles could not go through because this plum pudding was consisting of positive
It would
charges.
stop at the sphere only, outside the sphere.
No, he is talking about the entire thing which is positively charged. So if at all it hits here, then it should deflect. It should reflect. It should
Because
deflect.
Thomson said the sphere is positively charged and inside the negative
Negative
ions.
Yes, the entire thing he said was positively charged. So he did not expect any of these alpha particles to pass through. But what did he see? he saw that most of them were passing through, and therefore immediately he was able to say that that model is totally wrong. Okay. At that point, I think we should really appreciate that, conducting experiment and able to see something that you cannot see itself was a remarkable thing. Continue.
Some of the most of the fast-moving alpha particles pass through the gold. Some of the alpha particles were deflected by the point by small angle. Surprisingly, 1 out of every 12,000 particles appeared to rebound.
Did you understand what is rebound see here? Some of them are getting deflected at very wide angles. Okay. Some of them are hitting the target, obviously at the nucleus, and it is coming back. Very small number is actually coming back. And based on this experiment, of course, he was able to tell us.
The following conclusions were made. Most of the space inside the atom is empty because most of the alpha particles pass through the gold foil without getting deflected. Very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. A very small fraction of alpha particles was deflected by 180 degrees, indicating that all the positive charge and mass of the gold atom was concentrated in a very small volume within the atom. On the basis of this experiment, Rutherford put forward the nuclear model of an atom which had the following features. There is a positively charged center in the atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. The electrons revolve around the nucleus in well-defined orbits. The size of the nucleus is very small as compared to the size of the atom.
Okay, so did you understand this part of it? So based on this, he said that was totally wrong, and this was what he has given. Okay, so this is also looking as if there is a sun, and you have got your various planets which move around. Okay, so this looks exactly like it. Therefore, this model is also called as a planetary model of an atom. Did you understand? With the sun in the middle and the various electrons around, so which looks similar to the planetary system, and therefore this is also known as a planetary structure of an atom. So according to it, what did he say? It is the central part of it which is positively charged, and the electrons are present revolving around the positively charged particles in certain orbits. But at that time, of course, we did not tell anything about how many electrons can be present in the first orbit, how many can be present in the second orbit. We did not know about all those things. Okay, all that he said that was electrons are negatively charged and they're all moving around in certain paths, and then he was able to call it as orbit. And we all follow how the development of the structure of the atom is actually taking place. But then further what happened, some other people started experimenting, they found out that if there is a charged particle, okay, pay attention now. If there is a charged particle which is moving around having a circular motion,
it would lose its energy.
Yes, it's an accelerated motion. Okay, so it would gradually lose its energy and keep on revolving, and it could probably fall into the nucleus because nucleus is positively charged and electrons are negatively charged. Okay, but gradually moving, and then of course there would be no matter. Okay, did you understand? The atom itself would get destroyed. But then we know that that is not happening. But he was not able to explain about this part of it. Okay, so there were a little drawbacks, but to a certain extent, his model has been widely accepted even now after so many years. Did you understand? So this is the basic idea of an atom. And he told us something about the mass. What did he say? The mass of this atom is concentrated only in the nucleus. Okay? And remember that at that particular point of time, they did not know anything about the neutrons. They knew only about the electrons
and protons.
And they also knew about the protons. They did not know anything about the presence of the neutrons. It came much later. Almost about 30 years later. Okay, it was another person who promoted this. Is it clear? Did you understand it here? Of course, then I have already discussed regarding the next one, which happens to be the Bohr's theory. Are you familiar with this? This we have already. Yes. So the first orbit, second orbit, and third orbit. And what is the formula here?
2xy.
2x. So Bohr was the one who took forward this idea of an atom, structure of an atom, and he was able to tell us a little more regarding the position of the electrons. So what did he say? He says that yes, this part of it is correct, that there is a central part which is positively charged. And he says that these electrons are present in certain defined areas, and he called it as energy shells. Okay, maybe you can also call it as an orbit. Why did he call it as energy shells? Because the electrons which are present in these shells have got a specific amount of energy. And he said that as long as this electron is moving in this electron, in a particular orbit or in a particular shell, it does not denote energy. You understand? And of course, he gave us this very simple formula, which is 2n squared. Depending upon which, you can actually find out how many electrons are present in the first shell, the second shell, the third shell, and so on and so forth. Okay? Kaushik, can you tell me now? The electron, let us say, which is present in the third shell. Okay? This is the first shell, second shell, and this is the third shell. Which has more energy, the electron present in the third shell or the one which is present in the first shell?
First,
What do you think?
First,
The ones which are present in the outermost shell have got more energy as when compared to the ones which are down. So what is the rule of filling up? First one is always the electrons have to fill up the first shell. Only when the first shell is filled up, then the second shell is filled up, then the third shell is filled up. Okay? Electron will not come directly into the third shell.
So the last one has the most power.
Magnitude of energy. Okay? So and it is always the electrons which are present in the outermost orbit which are taking part in our chemical reactions. Is that clear? Okay. So do the protons take part in chemical reactions? Do the electrons take part in the chemical reactions? No, it is present inside the nucleus. Okay. So usually this part of
protons don't take
they
part
don't
in the
take part. And this is in chemical reactions. But if you're talking about the nuclear reactions,
then
okay, then possibly it's not a chemical reaction, there is some other type of reactions, radioactive reactions that it can actually
and protons will take.
take. There are the possibility of that as well. Did you understand? Because radioactive decay is a nuclear phenomenon, something that is taking place from inside the nucleus. Is this okay? Is it clear? Chalo. Read Bohr's theory.
In order to overcome the objection made against protocol model, we offer all the atoms need board put forward the following students about the model of an atom. Only certain special orbit known as discrete orbits.
Discrete orbits means orbits which have got a discrete amount of energy, a specific type of energy.
Discrete orbits of electrons are allowed inside the atom. While revolving in discrete orbits, the electrons do not radiate energy. These orbits of shells are called energy levels. Energy levels in an atom are shown in figure. These orbits or shells are represented
What is the alphabets? What are the alphabets which are given? The first alphabet? Yes, it's starting from K. So the first one is K. You have got L, M, and so on and so forth.
and
So K, of course, is your first orbit. Correct?
These orbits or shells are represented by letters K and M or the number N equal 1, 3, 4. New marks that you need.
Yes. See here you have understood and see about Bohr and for the amount of research and for putting up this particular structure, which we all accepted it. Once again, in 1922, he was awarded the Nobel Prize. Okay, so we have got a lot of people who have won the Nobel Prizes. And luckily, whatever research that they have done, it still holds good. Or probably it is paving the foundation for what is going to come up later. Did you understand? See, right now we are accepting electronics, the advancement in communication is so fast. But if you look up 50 years back, it was so bad, you probably had to rely only on telephones. Okay, now there were no mobiles at all. Okay, yeah. So you see how the advancement has taken place. And maybe another 50 years, Things will be so different. You never know. Because of all the research that people are doing it right now. Have you followed now? Do you know about AI now? What is AI?
Artificial
You
intelligence.
never know what is going to come up. Okay, to what extent things are actually going to open up. Within the next year, 10 years, 15 years, things will be so different. And communication and application of AI in so many aspects will be so different. Correct? So we have to appreciate regarding what is happening. You will put your feet inside. Or you go and sit there. Correct? Did you understand? Okay. Then comes, of course, neutrons. So we have said that neutrons were not known at Bohr's time. Okay? And one of Bohr's students was Chadwick. So he started doing some more experiments and he said something about atomic mass. Okay? When you know that electrons and protons are present, and we know that the mass of electrons is almost negligible. That means we are not going to consider the mass of an electron. But the mass of the proton and the mass of the atom itself was not matching. Do you understand what I'm saying? The atomic mass was much more as when compared to the total mass of the protons. So that is when he said that probably there could be another type of a particle which may be present, whose mass of a neutron should be very similar to the mass of a proton. Okay? And that is how neutrons were discovered. And he said it is neutrally charged. Okay? And this neutron obviously has to be present within the nucleus itself. Got it? Read that.
Adding to the J and Chadwick discovered another subatomic particle which had no charge and a mass nearly equal to that of proton.
Mass nearly equal to. Okay? Did you understand? The mass of the proton is almost equal to the mass of the attention.
It was eventually named as neutron. Neutrons are present in the nucleus of all atoms except hydrogen.
Did you understand why except hydrogen? You remember last time I made you draw 3 isotopes. First one is what you look at your notebook now. You will understand. Look at your notebook.
One had one proton, one electron.
Yes. All of them will have proton and one electron. But the first one, the first atom, it has no neutron. Okay? Except hydrogen, which does not have a neutron, and that is why hydrogen is said to be one of the lightest elements. Right? Continue, please.
In general, a neutron is represented as the mass of an atom is therefore given by the sum of the masses of proton and neutron present in the nucleus.
Yes.
Mm.
Is that okay?
Yeah.
Okay. Now the next part of it, of course, we have already finished. How electrons are distributed. You see that? We have completed this valence electrons. You remember all that? Okay. Then we have finished, completed atomic number, atomic mass number, isotopes. Everything is over. Last is isobars. Okay. But last part I am going to talk about isobar. And I'll give you some notes also today, so that we have completed, and we will do the question and answers.
What is the last chapter?
Yeah, nothing else to do on this. Now, what is an isobar? Okay, we are giving you 2 different atoms. Look at the board: calcium and argon. Okay, farad 18 here. What does it mean? Farad 20 here. What does it mean?
Subscribe.
Yes. So, how many protons, electrons, and neutrons we have to write for each one? How many protons? This is how many?
Map protons are
20.
20.
Your electrons?
20.
Neutron will be
40.
40.
neutrons are 40.
Mhm.
Neutrons are also 20.
Yes. You remember this number? What does this number tell us? It tells us the atomic mass number. Correct? So this is your A and this is your
Z.
Z. If you want to find out the number of neutrons, it is A minus Z, which is 40 minus 20, which is equal to 20. You understand? Okay. Now, let's talk about argon. Did you notice something here? What is similar?
A.3.
The
This is
number,
when-
atomic number,
Atomic
mass
mass
number.
number. Okay. Are the atomic numbers similar?
No,
So let's calculate now how many protons, electrons, and neutrons. Yes, Abhishek, take me. Protons how
18.
many? Yes.
18,
Yes, and neutrons.
22.
22, yes, no,
18.
32,
40 minus
32,
40 minus 80.
40 minus 18 is how much?
22,
Yeah, 20 आया now. We have already
22,
calculated 20. So it has to be 22. Two more than that. See, so just two more. Okay. So now what can we make out? That the protons and electrons are different, but atomic mass number is the same. Okay, everything is different. Protons is different, electrons are different, the number of neutrons are also different. Okay, now can you give me a definition? Can you give me a definition? Don't look at it. Atoms of the same element, are they atoms of the same element? Atoms of different elements,
seven different atomic mass numbers.
not mass numbers, atomic numbers.
Atomic
numbers are
atomic
different.
numbers have
Ah.
different.
Ah.
Can have the same, having the same atomic mass numbers are called the isomers.
Excellent. Excellent. Come on, right now. Isobars. I first finish the isobar part of it, and then we will talk about the others. Meet inside or you go towards the corner. Go there. Go to that corner. Isobars. Ready? Atoms of different elements, right, neatly? Right, neatly. Of different elements having different atomic numbers, having different atomic numbers, but the same atomic mass number, but the same atomic mass numbers are called as isobars. Okay. Now, one of the questions that they have asked here, see here, they have asked you a question here, right? They're asking you write the electronic configuration for one pair of isotope and isobar. Now, I'm not talking about isotopes. We'll write only about isobars. Okay. Write down. Example. Example. Calcium and argon. And this is the information which is given to you. These are isobars. So they're asking you to draw the electronic configuration. How will you do? What do you show? This is the nucleus, first orbit, second orbit. Do we require a third orbit also?
Yes, ma'am.
Yes. So the first circle that I have shown, obviously it's not. So you have to show both proton and neutron. Correct? How will these electrons be distributed? 20. What will be the electronic configuration?
2,
Yes.
4,
2 comma
4, comma
4 sounds here.
A 2 comma 8.
2, comma 8,
Ah,
and then 8, 8.
2 comma 8 comma 8 comma 2.
Another third orbit is there only 18 or 8?
The maximum capacity is 18.
So why are
Why we are not putting this 2 here? That is your question.
18.
Isn't it? Yeah. Because if you look at a composition of calcium in the periodic table, there's another subshell which begins to form, that is the D shell. You will understand about this concept a little later. Once you remember something about S, P, D, and F, that part of it we have not done. All that we have to remember is 8. If it is 8 in that particular shell, it gives a special type of a stability. Okay? So this is your electronic configuration. So now come on, fill it up. So first orbit will be 2, second will be 8. Okay. The third one also will be 1, 2, 3, 4, 5, 6, 7, and 8. And then we require another orbit which basically tells us that there are 2 more electrons. So you write down this is important. 2, 8, 8. Now tell me how many protons should we put inside the nucleus? Should we put 40 in your neutrons? How many protons?
20.
20 protons. And how many neutrons will you have?
20.
Yes. So this will have 20 protons and 20 neutrons. Okay. Remember the formula, number of neutrons for calculating, it is A minus Z. So in this particular case, it is going to be 40 minus 20. Okay. Now, let's tackle argon. What's argon? This will be the nucleus, first orbit, second orbit, third orbit. Let's see if it requires a fourth orbit.
Good.
Yes. Z is equal to 18. So your electronic configuration will be 2, 8,
2, 8,
what?
8,
8,
4.
Why 4? 18 only, no? 8 plus 2, 10. 10 plus 8, 18. Total should be only 18, not more than that. Correct? So in the first orbit, we will have 2. Second orbit will have 8. 1, 2, 3, 4, 5, 6, 7, and 8. And the last orbit also will have 8. Why do we call it as isobar? Tell me, why is it called as an isobar?
Because the number of atomic.
Huh? Tell me, why is it called as an isobar?
Because
Look at the board and tell me.
if there's different atomic number,
And then what is similar?
right?
Some numbers are similar, no? What are these numbers in the top?
18.
40 and 40. What is that 40? Atomic
No,
mass number. What is similar?
mass.
Yes. This atomic mass number which is similar. But so there are all different examples where we talk about. These are isobars. Okay. Now there is something else for the symbol H, D, and P. What is that H, D, P? Tabulate 3 subatomic particles found in each one of them. Can you recognize anything? H is for hydrogen, D is for deuterium. Deuterium. Then these are all isotopes of hydrogen.
Tetraatomic.
And
Tritium.
tritium. Okay. Hydrogen, deuterium, and tritium. So those are the isotopes of hydrogen. See, it's given here. See here.
Protium, dentium.
We have already done that. Okay, I've made you draw in the notebook also. Okay, come on now. This part of it is done. I want you to write something about the name of the scientist and which year they have got the Nobel Prize. It's only for you to remember. Nobody's going to ask you. It's just only for our own interest. The name of the scientist, which we have in mind, and obviously you'll be talking about what was their experiment. Okay, discovery of electron or proton or those. First one was what? Who was the first person?
Dalton.
Dalton. So I'm going back. Go back to the third chapter. Okay, so we will write down the name of the scientist. Okay. First one was Dalton.
Dalton.
And in which year? Something. And what was his contribution?
Dalton.
Of course, it's given there. In 1808, he presented his atomic theory, which was a turning point in the study. Okay, so it was in 1808.
Even the Nobel Prize in 1808.
No, he presented. He did not get Nobel Prize. Okay. So what was his contribution? Dalton's atomic theory. And we know what are the postulates of Dalton's atomic theory. Correct? This was given on page number 27. Make a note of it in your notebook. Page number 27. What did he say? All particles are very tiny. Okay, they are all neutral. Each atom is neutral.
I have told this to write another.
Yes. This is with reference to chapter number 3. Okay. Now the next thing that we are going to write, which is there in chapter number 4, is regarding J.J. Thomson. And in which year did he win? He was awarded in 1906.
And this theory.
1906.
Thomson.
Sir J.J. Thomson. And what was his model? What did it look like?
Christmas pudding.
Correct.
He presented his theory in 1906.
He got the Nobel Prize. Yeah.
And what was the name of this?
Theory. He did not present any theory as such. He presented the structure of an atom. We are talking about the contribution. What did he do?
Structure of atom.
So it was like, yeah, right up. So similar to the model of an atom, similar to Christmas pudding. Right up. Atom.
Contribution.
Yeah, the contribution. Atom similar to Christmas pudding. Now you remember, no? What did he say? What was the sphere? A sphere of positive charges in which the negative charges were negative. Next scientist is regarding Rutherford. In which year did he get Nobel Prize? It was in 1908. Rutherford, 1908. Okay. And what was the name of his experiment? Alpha ray scattering experiment. Yes. Alpha ray scattering experiment.
Contribution was.
Alpha ray.
Alpha ray scattering experiment. If you remember alpha ray scattering experiment, obviously we can talk more about it. Who's the next person?
Oh.
Easy. And in which year? 1922. Most important contribution was this formula. What is this formula? Means both formula. Correct. So his formula was 2n square, and he said that as long as the electrons are present in these orbits, they don't give off energy.
No, okay.
Last one is what?
J, Z.
The last one.
Chadwick.
Child.
And it was in 1932. 1932, discovery of neutron.
We did one Nobel Prize.
We got no?
In
1932. 1932, we discovered another subatomic particle which had no charge. No, it is not given here, but he also won. Discovery was in 1932. After a couple of years, they will get a prize. After it has been done. So we have covered all the 4 people. Okay, who have contributed a lot towards the structure of an atom. Are you clear about this lesson? Yeah. Now let's see a couple of questions here. We'll do this.
4 minutes.
So what we can do it? Come on. This is on 19. Question number 19. Complete the following table. Abhishek, you want to go there? Sit there.
Yeah.
But I don't want you to see the answers. You cover the answers, you don't get the questions. So don't look at this videos. I'll put it up on the board, you can take a look. Let's do atomic number, mass number, according to whatever is given. How do we write atomic mass number?
Atomic mass number.
Atomic
9.
number,
Z.
atomic mass number, the number of neutrons, protons, electrons, and the name. So how many columns? 1, 2, 3, 4, 5, and 6. Yes. And make small columns, otherwise with your handwriting. Don't look at the answers. You work it out yourself. No, don't even look at that. You will be able to do it. Okay, I'll help you. Don't worry. So atomic number, first we'll write down. Go according to what I'm saying. Okay. What is atomic number? Is it Z or A?
9.
Z or A?
Like Z, atomic mass.
This is Z, and this is A. Okay. I'm writing it down here. Z will come here. A will come here. Okay, now. Atomic number is 9. This is given to us. The moment atomic number is 9, what else will be 9 and 9?
Proton and electron would be 9.
Correct. So proton will be 9, electron also 9. Next thing that is given is number of neutrons. They have given as 10. So what is atomic mass number? What plus what? Mass number is what?
Proton plus electron.
Atomic
What is
number.
inside the nucleus?
Proton plus neutron.
Yes. So proton and neutron. So how much will it be here?
90.
Yes. Okay. Now you have to tell me with respect to the name. What is the name? Which
Fluorine.
element will have 9 as atomic number?
Fluorine.
Fluorine. It's fluorine. Okay. Just draw and keep it. Next time we will work it out. Right? Thank you.
Next one.
Which chapters do you have for your?
Ma'am, I actually want to pass.
Yeah.
Tomorrow is my exam, so Can you just tell me any questions?
So many questions we have discussed. First 3 chapters you have it. First
First 2 chapters of chemistry, first 2 chapters of bio.
first 2 chapters का आराम से already you are quite very prepared. That's not it. Because you have already written tests also. All the best, do well.
Firstly, second chapter. वो भी इसका आ रहा है वैसे फिजिक्स का आ रहा है.
सेकंड चैप्टर नहीं वाली है
सेकंड चैप्टर केमिस्ट्री ठीक है भाई हो गया.
फर्स्ट चैप्टर
फर्स्ट चैप्टर
बहुत बार हजारों बार दिया
या बहुत इजी है फर्स्ट चैप्टर वेरी गुड. सेकंड चैप्टर थोड़ा भी ठीक है हो जाएगा. मुझे बायो का टेक्सचर में एक प्रॉब्लम है हुआ तो
निशाद एक तेरा काम ने चुरा लिया हमने किया नाम और चीज़ I don't know.